This is assignment 8.w. The first problem, it's set up in standard form. It already has the x squared, the 9x, and the 18, where it's the biggest exponent, the medium one, and then the constant, and then equal to 0, which is what you want. That means you're going to make this x to organize your information. The 1 and the 18, the 8 and the c value multiply to make the top number, so you get 18 up here. And then the b value, the negative 9, goes down to the bottom. You're going to be looking for the factors of 18 that add to give you negative 9. Because the 18 is a positive, that means you're going to add the numbers. 1 and 18 is 19. That's not the one we want. We want a 9. 2 and 9 would be 11. We don't want that one. 3 and 6 makes 9. Because we want it to be a negative 9 though, we're going to make it a negative 3 and a negative 6. So that when we combine them, they give us negative 9. And when we multiply them, the negative times the negative will make it a positive 18. Now that we know our two factors of 18 that we want to use, we're going to set up our parentheses. The x squared is going to get split, so 1 here, 1 here. And then the minus 3 and the minus 6, those two factors are going to fill out the right side of those binomials. Now we're going to set both of these equal to 0. Sorry, it's supposed to be a 6. We're going to set both of these equal to 0. And x minus 3 equal to 0, x minus 6 equal to 0. If you add 3 over here, you find out your x is worth 3. And if you add 6 over here, you're going to also get 6 for the x value. Next problem, same process. So it's already in standard form, x squared, x, and then the constant. 0 is over here on the right side. This is exactly what you want. Set up your x to organize your information. 1 times 4 is going to be 4. The 5 goes down to the bottom. You're still looking for the factors of 4. And those are the only pairs that'll make 4. You look for which one is going to add, because it's a positive number. Which one are you going to add and give you a 5? So 1 and 4, that gives you 5. 2 and 2 would have only given you 4, so you don't want that one. Now that you have your factors, the 1 and the 4, now we set up our parentheses. The x gets split. The 1 and the 4 are your two second terms right here and right here. Set each one of these binomials equal to 0. So x plus 1 equal to 0, x plus 4 equal to 0. And then solve by doing the opposite and being fair. So if you subtract 1 and subtract 1, you're going to find out that this answer will give you negative 1. If you subtract 4 and subtract 4, your other answer is going to be a negative 4. So those would be your two solutions. Next problem. This is the difference of two perfect squares. N squared is a perfect square, 64 is a perfect square because it's 8 times 8. When you have this, you can still do this form with using the x. Your b value would be at 0, but there's a shortcut, there's a faster way, and so we're going to use it. You know you're going to come out with binomials like that, just like over here where you had two of them, and you know that n squared is going to go 1 on each one of these two binomials. And now that 64, you're going to square root it, and that'll be the second term on both of those binomials. And the reason why there's no b value is because if you have a negative 8 and a positive 8, they cancel each other. So the signs have to be different here. And now you have your two factors. You can set them equal to 0 like we did on the first two problems. So n minus 8 equal to 0 and n plus 8 equal to 0. Over here, if we add 8 to both sides to get n by itself, we find out we get 8. And if we subtract 8 to move this one over, we're going to get negative 8. And those would be your two answers. So on this problem, if you look, b squared and b can both be divided by b. So if I factor a b out of both terms, b squared divided by b is b, and then 5b divided by b would be 5. Your first factor would be b, make that equal to 0. Your second factor is b plus 5, make that equal to 0, and then solve them. b equals 0, that's already solved. There's nothing to do there. b plus 5, you're going to subtract 5 to move it across, and your second answer is going to be a negative 5. For number 5, 35, 22, and 3 are your a, your b, and your c values. That means you're still going to do this x to organize your information like we did on the first two problems. 35 times 3 is 105. And then 22 goes down here. Since I can see a 5 right here on the end, I know I can divide by 5. So if I divide by 5, I get 21. And now that I see the 21 is factored, That means that I could also have used 3. So let me try it with 3. So 105 divided by 3, I have 35. I saw that 21 was there, which means, and 35 is there. That means I can divide by 7, because both of these can be divided by 7. So if I use 7, I'd go 105 divided by 7. And I think I just found my 22. So I'm looking for the product of these numbers that's going to give me 105, which all of these do that, but it also has to be able to combine and give me 22. Since it's positive here, the signs are both the same. Since it's positive 22, that means they're both positive. So this would be 26, that's why it didn't work. This would be 38, that's why that didn't work. 7 and 15 is the 22 we were looking for. So those are our factors. Now that we know the factors of 105 that give us 22, now we're going to set up our two parentheses. We're going to put 35n in front of both of these, and then the 7 and the 15, those are going to go as the second terms. And now we have an extra step, because the n wasn't by itself. We had a number in front. We had a different number besides 1 for our a value. That means that we're going to have to divide both of these by their greatest common factor. And when we get that out, we're not going to put it in the front. It's part of the process. So 35 and 7 can both be divided by 7. 35n divided by 7 is going to be 5n. 7 divided by 7 is going to be 1. And then over here, 35 and 15 can both be divided by 5. 35 divided by 5 would be 7, so this is 7n. And 15 divided by 5 would be 3. So that would be plus 3. So those are our two factors. We still have to set these equal to 0, and we're still going to solve them and find out what we get. So if we get 5n plus 1, make it equal to 0, and 7n plus 3, make it equal to 0. On the first one, you'd subtract 1, you'd have 5n equals 1, then you would divide by 5. So your first answer is 1/5. Then your second answer, you would subtract 3 to move it across, you'd have 7n equals a negative 3, and then you divide by 7. So it'd be negative 3/7. So those would be your two answers, 1/5 and negative 3/7. Number 6, same process, 15 and 4. You multiply those two together, that's 60, but it's positive and negative, so this is negative 60. On the bottom we have a 4, and now we're looking for factors of 60, so we have 1 times 60, we have 2 times 30, we have 3 times 20, we have 4 times 15, we have 5 times 12, we have 6 times 10. So we're looking for a pair of these that will subtract, because it's negative 60, and give us a 4. So this would be 59, this one would be 28, this would be 17, this would be 11, this one would be 7, and then 6 and 10, 10 minus 6 would be 4, so that's the one that we wanted. Once we have the numbers, for the signs, we want it to be positive, so that means the bigger one's the one we want to be positive. It has to be the same sign as this, and the other one has to be different, so it has to be the negative. Now that we have our two factors of negative 60, we're going to do our parentheses. That 15b is going to be in front of both of these. Negative 6 and positive 10 end up being our second terms. Make each one equal to 0. 15 minus b equal to 0. 15. Before we can set them equal to 0, remember that we have to look for greatest common factors in here. 15 and negative 6 can both be divided by 3. That's going to be 5b minus 2. And the other factor, 15 and 10 can both be divided by 5. So you're going to get 3b plus 2. And if we set those equal to 0, we'd go 5b minus 2 equal to 0, 3b plus 2 equal to 0. You would add 2 to move it across the equal sign. You'd have 5b equals 2, and then you'd divide by 5. So the first factor is going to give you 2 over 5. The second one, you would subtract 2 to move it across. You'd have 3b equals a negative 2. You divide by 3, and your second answer would be negative 2 over 3. For number 7, still in standard form, still have the 0 over here by itself, so it's set up the way we want it. Multiply 7 and 24 to fill out the top part of the x. You get 168, and it's a positive 7 and a negative 24, so that's negative 168. The b value is going to go down to the bottom, so that 38 comes down here. We have to find our factors of 168 that give us a 38 when we add them together. I can divide by 2, and it would be 2 times 84. That still didn't give us what we wanted, 38. Then we'd go 3 times 56, and then if we subtract that, that's 53, still not 38. 4 times 42, and if we subtract that, there's our 38. So we don't have to keep finding factors, we can stop right there. And then we want it to be a negative answer at the end, so that means the bigger one this time is the one we want to be negative. The 4 is still going to be the opposite sign, so that we subtracted to get this, and it's different signs because that was a negative 168, so this is going to be a positive 4 over here. And then now we're going to do our parentheses. 7p is going to be the front of both of them, the first term for both of them, and then the 4 and the minus 42 will be the second terms. We have to factor out the greatest common factor. 7p and 4 don't have one, so it's just 7p plus 4, and we can already make that equal to 0. Over here, 7p and 42 can both be divided by 7, so that's going to be p minus 6. We can go ahead and make that equal to 0. And then over here, you would subtract 4. You'd have negative 4 over 7 for the first one. And then for the second factor, we would be adding 6 to both sides, and we'd have a positive 6. So those would be your two answers. For number 8, 3, 14, and 49 is in the correct order. 0 is by itself. So that means we're going to fill out our x. 3 times 49 is 147. It was a positive 3 and a negative 49, so it's a negative 147. 14, the b value comes down to the bottom. And then we're going to have to find the factors of 147 that subtract and make a 14. So 1 times 147 isn't going to work. 2 times 147 is still not going to work because it's an odd number. 3 will work because we already have that one. 3 times 49 is how we got to this 147. So we start there, 3 and 49. But we subtract that, we only get 46, which is not 14, so not the number we're looking for. Then we look at 4 doesn't work because it's not an even number. 5 doesn't work because it doesn't end in 0 or 5. 6 doesn't work because it's not an even number. 7 can be divided into 49, so let's try 7. So this side would be 21. And then 7 and 21, if you subtract those, that's going to give us the 14 we're looking for. We want to combine those and get a positive 14, so the smaller one's negative, the bigger one's positive, so that the bigger one will give you the sign you're looking for. Now we set up our parentheses. The 3x squared is going to give us our first term, just don't put the squared on it. The negative 7 and the positive 21 are the second terms. After that, look for the greatest common factors. This one doesn't have them, so it's ready to be put equal to 0. 3x plus 21 can both be divided by 3, so we're going to factor a 3 out of there. It's going to be x plus 7 equal to 0. And then you're going to add 7 to move it across, so you'd have 3x equals 7, and then divide by 3. So your first answer is going to be 7/3. Then your second answer for x plus 7 equals 0, you would subtract 7 on both sides, and you would get x equals negative 7. For number 9, 3, 18, and 21 can all be divided by 3. So if you factor a 3 out, you're going to get k squared minus 6k minus 7 equal to 0. So I divided 3k squared by 3, got k squared. Negative 18k divided by 3, got negative 6. Negative 21 divided by 3, negative 7. Now I can do my x, because I found out that there was a greatest common factor, and I factored it outside. So the 1 and the 7, I'm going to ignore this 3 right now. The 1 and the 7 goes to the top. Positive and negative makes this negative. The negative 6 comes down to the bottom, that's the b value. Factors of negative 7 can only be 1 and 7. We want the bigger one to be negative because it ends up being a negative 6. So it's going to be a positive 1 and a negative 7. Now that we have those, put 3 in the front. Over here, we're going to have k in the front of both of these binomials. Then the plus 1 fills out the first binomial. The minus 7 fills out the second one. The 3 equal to 0 doesn't work. K plus 1 equal to 0. You're going to subtract 1. And then k minus 7 equals 0. You would add 7. So those would be your two answers. It'd be a negative 1 and a positive 7. Number 10, 6, 42, and 72 can all be divided by 6. So if we factor out a 6, we get k squared minus 7k plus 12 equal to 0. Setting up our x, 1 times 12 is 12. Positive and positive is positive. Negative 7 comes down here. Factors of 12, 1 times 12, 2 times 6, 3 times 4. The ones that combine and give us a 7 would be the 3 and the 4. We want them to be negative, so that when we add them together, they give us a negative 7. Even though they still give us a positive 12 when we multiply them. Then we set up our factors of the quadratic. So k is your first term, minus 3 and minus 4 are your second terms. If you put 6 equal to 0, it doesn't work. K minus 3 equal to 0 is going to give you 3 as one of your answers. And then k minus 4 equal to 0 is going to give you a 4 as your other answer. Number 11. This is not in standard form, so we need to move things around. We're going to subtract 11x to move it across. We're going to add 21 to move it across. So when we rewrite it, it's going to be a negative 11x because it moved across the equal sign. It's going to be a positive 28 because we moved across the equal sign. And on the right side, we have a 0, which is what we wanted. Now we can set up our x. 1 times 28 is 28. The negative 11 goes down to the bottom. We're looking for factors of 28. And we want them to add up because it's positive 28, so the signs are the same. We're going to add up and get a negative 11. So 28 and 1 would be 29. 2 and 14 would be 16. 4 and 7 would be 11. 4 and 7 need to both be negative because we want to have negative 11 when we combine them. And then we set up our parentheses. X goes as our first term. The minus 4 and the minus 7 are our second terms. And then when we make x minus 4 equal to 0, we add 4 to both sides. One of our answers is 4. When we get x minus 7, make it equal to 0. We're going to add 7 to both sides, and we're going to get a 7. Number 12, it's not in standard form because the 0 is not over here. We need to move this negative 56 to the left. So we rewrite this one. So it's going to be k squared, already there, plus 15k is already there. And we're going to move that 56 across, so it's going to be positive 56, and then equals 0. Now we set up our x. 1 times 56 is 56. We're looking for factors of 56. We keep going until we find our factors that add up to make 15. The 7 and the 8 are our factors. I apologize, the 15 should have been down here, but I knew that was what I was looking for, so sorry about that. The parentheses, still set up the same way. K squared gets split to make our first term. The 7 and the 8 become our second terms. Set them equal to 0. If we subtract 7 from both sides, one of our answers is negative 7. If we subtract 8 from both sides, the other answer is a negative 8. Okay, for number 13, not in standard form, we need to move this around. So if we add 16m, we'll move it across. If we add 21, we can move it across. So when we rewrite this, 3m squared was already on the left. Don't change that. 16m, once it crosses that equal sign, becomes positive, and the 21, once it goes across that equal sign, also becomes positive. So that now our new equation is 3m squared plus 16m plus 21 equal to 0, and that's in standard form. 3, 16, and 21 don't have a greatest common factor. There's nothing in common that you could divide in all three of these. So the 3 and the 21 get multiplied together. That's 63. It's positive and positive, so it's a positive 63. 16m goes to the bottom. You're finding factors of 63 that add up to give you 16. So if I go 3 times 21, that didn't work because that gives me 24. If I go 7 times 9, that gives me 16. So that's the pair that I want. We want it to be positive, so they're both positive 7 and positive 9. When we set up our parentheses, the 3m squared is going to give us a 3m for our first terms. Positive 7 and positive 9 are our second terms. Since they're set equal to 0, 3m plus 7 equals 0. When you solve that, you get negative 7/3. 3m plus 9 needs to be factored out. It's going to be m plus 3 equal to 0. And that's going to give us, when we subtract 3 from both sides, a negative 3. Number 14, you need to move these across the equal sign, and on top of that, they're not even in the right order, so make sure that when you rewrite it, you put it so that the x squared goes first, and then this 43x moving across is going to be negative 43x second, and then the 30, when you move it across the equal sign, is going to be minus 30, put that one third, and then 8, 43, and 30 don't have anything in common, so you're going to multiply 30 times 8 for that x, and then the negative 43 is going to be at the bottom. You're looking for factors of negative 240. And you want them to subtract and give you 43. So this one gives you 239. This one would be 118. This one would be 77. Over here, 4 times 60. If you subtracted those, you'd get 56. And then 48 minus 5 is the 43 that we wanted. Once we have our two factors, remember that we want the bigger sign to match this one. So the bigger number is 48. We want that to be a negative. And we want the signs to be different. So this 5 has to be positive. And then we set up our parentheses. 8x squared is going to give us 8x for both of these in the front. The 5 and the negative 48 give us our second terms. 8x and 5 don't have a greatest common factor, so you can make those equal to 0. 8x and 48 do have a common factor. They can both be divided by 8. So if you divide them by 8, 8x divided by 8 is x. 48 divided by 8 is 6. And then now you set them equal to 0, now you can solve them. So 8x plus 5 equals 0. When you work that out, you're going to find negative 5/8. And then when you add 6 on this other equation, you're going to get a positive 6. And those would be your two terms. This 3x, if we subtract it from the 17x, is going to give us a 14x. Now that we have that, we can set up our x to organize our information. The 1 and the 49 will give us a 49 for the number on top. 14 is our b value that goes down to the bottom. I'm already getting tired of doing these, so 7 and 7 makes 14 when you add it together, and 7 times 7 makes 49. And then setting up our two parentheses, the x squared gives us x and x. The 7 and 7 are our second terms. They were both positive. So we don't have any greatest common factor to deal with. If you put x plus 7 equal to 0, when you subtract 7, you're going to get x is 7. In this case, if you look, they're the same factors twice, so we don't need to do it again. We can just say there's only one answer. Number 16, we want to put this 2m on the left side of that equal sign. So to move it across, we subtract 2m from both sides. And now that we have it equal to 0, this problem is very similar to what we did in number 4. You're just looking for the greatest common factor between them. They can both have an m divided out of them, and that means you would have m minus 2 equal to 0. Then you go m equal to 0 and m minus 2 equal to 0. First one's already done. And then m minus 2 equal to 0, if you add 2 to both sides, you're going to get 2 as your second answer for number 16. Number 17, it's not in standard form. We need to move this across. Check to see if there's any greatest common factor we can get out, but there isn't. Set up our x, multiply the 2 on the outside, the a value and the c value. The b value ends up being the number in the middle. After that, you're looking for the factors of 28. Like I said, I'm getting tired, so it's 7 and 4 makes it. 7 minus 4 is 3, 7 times 4 would be 28. You want the bigger number to be positive because the 3 is positive. The smaller one's negative because it has to be different. The parentheses, you're going to have 2k in the front for both of them. And the positive 7 and the negative 4 are going to be your second terms. Since it's getting crowded, 2k plus 7 equal to 0. When you work that out, you'll find out your first one is going to give you negative 7 halves. And then if you do this one, you can factor a 2 out. You get k minus 2 equal to 0. Then you're going to add 2 to both sides. Your second answer is going to be a positive 2. Number 18, you need to move this 8v to the left by subtracting 8v. And you get 28v. After that, 3 and 28 and 49 don't have anything in common that you can factor out of them. Set up your x. 3 times 49 is 147. And then this negative 28 comes down to the bottom. Since we already saw on number 8 that the factors of 147 were 3 times 49 and 7 times 21, if you use that, and the signs are supposed to be the same, 3 and 49 would have been 52. 7 plus 21 is going to give us this 28 that we want. So we're going to go ahead and use those same factors, 7 and 21, in problem number 18. But we want to use negative 7 and negative 21 so that when we multiply them together, they're going to give us a positive 147. And when we combine them, we get a negative 28. Now we can set up our parentheses, and then 3v on both binomials. The negative 7 and the negative 21 are going to be your second terms. This one does not have a greatest common factor, so you can go directly to 3v minus 7 equal to 0. And then you find out that your first answer, if you add 7 and divide by 3, is going to be 7/3. And then this one, 3v and 21, do have a greatest common factor, so you factor that out, you get v minus 7 equal to 0. And then you're going to add 7 to both sides, so your other answer is just going to be a 7. If you add 12 to both sides, you get 10x squared minus 26x plus 12 equal to 0. Now that we have that, we look for greatest common factors here. All of these are even numbers. They can be divided by 2. So we're going to simplify this by dividing all of these by 2. And the reason we can do that is because the 0, if you divide by 2, stays a 0. You get 5x squared minus 13x plus 6 equal to 0. Now we set up our x. 5 and 6 is 30. It was positive 5 and positive 6, so it's positive 30 when you multiply them. Negative 13, the b value comes down to the bottom. Factors of 30 could be 1 times 30, which would be 31. It could be 2 times 15, which would be 17. It can be 3 times 10, which would be 13, and that's the one we want. So 3 and 10, so negative 3, negative 10. Set up your factors, your parentheses. The 5x goes on the top, on the front of both of these. Negative 3, negative 10. Now we're going to set each one equal to 0. This one, you can find the greatest common factor, so that 5 gets divided out of both of these. It's just x minus 2. Solve this. You find out your answers are going to be, if you add 3 and divide by 5, 3/5. And if you add 2, positive 2. Those will be your two solutions. Number 20, last problem. We need to move this 80p to the other side of the equal sign. So 15p squared stays on the left. Negative 80p, when it comes over, becomes positive 80p. This 80 was already on the left, so it stays 80. And since we move this negative 80p out of the right side, we have a 0 on the right. 15 and 80 and can all be divided by 5. So we factor a 5 out of it. Now we have 3p squared plus 16p plus 16 equal to 0. 3 and 16 multiply together. That makes 48. 16 down here at the bottom. Factors of 48. 1 times 48, 2 times 24, 3 times 16, 4 times 12, there it is. So the 4 times 12 will multiply to make 48, and 4 plus 12 will give you a 16. So those are your two factors. 3p goes to the front of both parentheses. 4 and 12 end up being the second terms on both of those binomials. 5 doesn't work because 5 equal to 0 doesn't make sense. 3p plus 4 equal to 0. That's okay because they don't have a greatest common factor. And this one, 3p plus 12, if you divide 3 out, becomes p plus 4. Now subtract 4 and divide by 3, and your first answer is negative 4/3. On the other term, you're going to subtract 4, and you get negative 4. And those are your two answers.